I have no microphone. I'm not sure if I'm supposed to have a microphone. We'll see if I need one. Hopefully I don't. No microphone? Excellent, no microphone. Okay, so my name is Ryan Barker, and I am architect at eHarmony. This particular presentation is Dating with Models, a how-to guide for programmers and architects. There is a corresponding presentation by Baclav. You get a presentation at QCon. You can get the links sent out, I think, which covers the modeling side, actually how to train models and, data gathering and, picking features and all that kind of stuff that I know about that much about. So I can talk some about that, but this presentation is mostly, you get these specifications from the modelers, and you need to go implement this in a scalable way to handle, scoring millions and hundreds of millions of, in our case, potential matches. So a little bit about eHarmony. We were one of the first companies to apply sophisticated models to the matching process, and we will go through the various kinds of models that we have. The first models were compatibility models, which is from our founder, Dr. Warren. He is a psychologist who was practicing for 40 years or so, and saw a lot of failing or failed marriages. And as far as I could tell, he didn't think some of these people should have ever got married. Their personalities were just so different, they had nothing in common. And Dr. Warren can't be here, and he can say this much better than I can, so we'll do him, which disappeared. Oops. That's him.
Dangerous, no doubt.
Marilyn and I can remember.
Okay, this was not happening earlier. So what we're going to do is cancel this and this.
It's a gorgeous day today. There are a lot of people falling in love today. Marilyn and I can remember the exact moment we fell in love. I felt for her something I had never felt for anybody else in my life. When I think about people finding the love of their life and us helping them find the love of their life, just the joy of that warms my heart. I was a psychologist in Pasadena, California for 40 years. Many of those cases that I saw were people who were having a lot of trouble in their marriages. So we started out saying that we would like to get the divorce rate from 45 to 50%. We'd like to get that down to less than 10%. So I thought to myself, wouldn't it be fabulous if you could get people off to a great start, so when they got bonded with one another, they were bonded for all good reasons that would hold through the crisis times of life. There's such a difference between a marriage and a great marriage. If you have a great marriage, it's just the thing you look forward to. There is no night in my life when I ever want to be with anybody else nearly as much as I want to be with Meryl. We just ended up with a marriage that was really well matched. Now what we figured out are these ways of matching so that you don't have to rely on luck anymore. We have a much firmer foundation for the putting together of two people so that their marriage can last for a lifetime. In the study that was done by Harris from 2005 to 2012, the divorce rate for eHarmony marriages has been only 5%. That's just a radical drop. It's better than all other marriages, better than marriages that come from meeting somebody at a bar or at church or at work or through a friend is a social revolution. You take away divorce from our society, you've taken away one of the greatest problems that our society has faced. We have 160 people who work for eHarmony, and every single one of them is into the mission. I think they work here not because it's a job, but because they want to help people find love. But let me tell you, another thing that we're doing at eHarmony, we're saying that there are other things that need to be matched in the same way. So, for instance, 40% of Americans don't have a single confidant. We want to get people with the right friendships. We want to get people into the right jobs. If you could get all of these things matched perfectly, you would have something like heaven on earth. It's going to change a whole generation and another generation and 1,000 other generations. It's going to turn society around. Honestly, we're not into it for business anymore. We're into it to change the world.
Okay, so that's Dr. Warren. So obviously we have this great mission statement, and if you wanted to, implement this, that's great to have a mission statement. There's some sort of models out there. You have sort of some vague idea of how to put together a website for this. So let's start with the fundamental idea. And
It's a gorgeous thing.
Okay, so fundamental idea, we have 320 questions originally. Now actually we're down to 150. We've gotten much better at this over time. So these are designed to find fundamental features about a human being, their personality, what values they have in life, their attitudes, their beliefs, and all of these things sort of come together to make up a personality. And so they sat down and they worked together with statisticians and came up with various algorithms. It's easier to explain by looking at this beautiful picture. So we have a male on the left, we have a female on the right. The blue dot is every sort of marriage. The red dot is a bad marriage. Blues are good, they're not divorced. And obstreperous, noisy, difficult to control. That's kind of mean. I'm probably a little high on that one. So a little annoying, I suppose you could say. Yes, we actually do have a feature in some of our models called obstreperous. Here's your vocab word today. Feel free to spread this to any of your friends. And so there's other things in here. Obviously, the problem you can see is it's okay if one person is a little annoying, but if both people are annoying, they annoy each other, and that doesn't work out. There's another feature, right? Romantic. Turns out that both people are very romantic. It works great. If neither one is romantic, it doesn't work as well either. So you see, from generating sort of graphs like this, they actually came up with models where you could put features together. And models look something like this. So this is part of the original 29 dimensions model, which I believe is somewhat still used in the marketing. We have much better models now, use more or less dimensions depending on the model. You actually score every single person with multiple models. But you can see over here, appearance has a high alpha in this case, and here's R scores, which hopefully someone here, the statistician, can explain to me. But all of these come together, and the modeling team will give you basically a formula at this point, right? They say, calculate all these dimensions by adding up these values, and then you're going to take the value here, multiply it by this, add it, these are linear models, so every single dimension here has a corresponding value to multiply by, you add them all together, and you get some score, okay? higher the score, the better in this case. Sometimes the lower score is better. And so let's build it. This is eHarmony version 1.0. Here we go. Very simple web app. You have the internet, you have a web app, you have a database. In this case, it's SQL Server. This is 2001. Okay, you have some sort of match table which has a user ID, the candidate ID. I think the candidate was the male, I believe in this case. And the female was on the other side. You have a user with a bunch of the user attributes, including the address and other things that are important for the search section of the code. And you have user factors, which has all the modeling things. There's an obstreperous and romantic and all the other ones that are listed. Okay? And the way eHarmony works, and the main difference it has between, say, Match.com. Match.com is simply a search site. So you say, I want, I'm going to go find females between, in my case, females between this age and this age, this ethnicity, this religion, all kinds of things. So long list of things to search for, and you enter your search on Match.com, and back from your results, if they sort in some order, and you get your hundreds of pages, and I mean, who has time for that, seriously? You're a busy professional, everyone in here, you don't have time to, go searching through thousands of results. This is not, something you really want to spend your time with. So eHarmony's idea is actually that we'll do matching. So one of the problems with the search site is you're not taking into account what the other person is looking for. I can go looking for a bunch of people living in New York if I want, but they're not going to want to talk to me. I live way too far away. Or age ranges is a common one, or even like religions, I'm not religious at all, right? And, some very Christian person might not want to date me. So we're a match site, so over here, there's a stored procedure. So each night, we generate 7 matches for each person. So the stored procedure, which is the original implementation of eHarmony, lasted quite a while. What it would do is it would, get a list of all the users we're going to try and make matches for, and just go one by one and try and make matches for each person, where you find a bunch of users who are within what we call self-selects, which is what each person is looking for. And we have this order by with, all the values are in there. And we take the top 7 or top 3, I think at the time, and we give those matches. And that's the website. We store it in a database in the matches table, and the web app just serves the matches table and fills out the user data, user factors, all that sort of stuff. Very simple site. I highly recommend if you're ever building something from scratch and you have no users, go with something like this. It's very simple. Until you have users, don't worry too much. You're going to be redesigning and finding all your problems as you build it. Don't end up with version 4 of the system on day 1, or someone else will beat you too much. Right? So there are problems with this design. Let's see. We have very early in the design, there was a problem. There were thousands of users. There were very few matches, and they were talking about giving people back their money. Like it was that big of a problem. Okay? And when you think about what is the actual problem here, and what happened is they ended up doing a line-by-line visual debugging of the stored procedure. And the problem, they're going through line-by-line, this is fine, wait, that's not supposed to be an and, that's supposed to be an or. And they change it, and the site says, yay, eHarmony exists today because of this. Okay? That was Carlos Marino and Steve Carter were going line-by-line.
You also had a typo in your order. On the last page.
That particular slide was, some of the slides here, some of the older ones are sort of lost to history. This is a, little bit of, historical excavation, and I'm giving you my version of what I think they designed it is, not necessarily what they actually, how they designed the original. But it is accurate enough.
Accurate enough.
Accurate enough.
I promise I will keep him honest on the holidays.
Yes, please no heckling from the audience. Some of the people in the room have.
Just curious, out of thousands of users, is that like 1% or 50%?
This
How big of a problem was
this
that?
was very, it was a very large problem. it went to a few matches a day to like many matches a day. Like it was
Like
you know,
10%
multiple
of your
orders,
subscribers.
multiple orders of magnitude increased by fixing this problem. Okay, that's how, like, it was a major problem. Okay? And over time, the database load was increasing. I'm not sure, there might be another slide about this, but eventually that store procedure took 28 hours. It's a nightly match run, so yeah, nightly and 28 hours does not work very well. There were various solutions for that. Many things have been done. You know, optimize the store procedure, you know, add some indexes on the tables, you know, try and throw more hardware at it, but, you know, SQL Server, maybe we can switch to Oracle, it should be faster. You know, new hardware, that'll be faster, but, you know, eventually it comes down. You hit the limits of your, you know, your architecture, you're gonna have to do a rewrite of some sort. And then you have a really big fundamental problem with the entire website. Ordering by compatibility doesn't work at all. This is a really big problem. Turns out that just because people, if they happen to somehow get married, they would stay together. It says nothing about whether they will send the initial communication or actually want to date in the first place. So yeah, compatibility absolutely does not work by itself. Compatibility as a concept works fine. If you actually manage to get people to marry, it works just fine.
So why that doesn't work?
Why? I will get to that very shortly, but the real problem is because it doesn't take into account user preferences and things like. I'll show. I'll get you later. Don't worry. It will become clear. So what can we do? We can try and change the store procedure, but in the long run, we want to find some new models that actually model communication as like a second phase. So we're trying to optimize for communication. After we've already done the first phase of making sure we have a bunch of compatible potential matches, we want to, you know, figure out which ones actually show people each day to maximize communication. Which gets us to this. So the ultimate solution is basically three parts. There's a compatibility matching, which is what I just discussed. There's affinity matching, which is what I sort of mentioned now, where you're trying to optimize for communication. But that's an individual user. Then there's mass distribution, which is the overall, there's this concept of trying to maximize the overall communication in the system. So for any particular user, you might need to give them less than optimal matches on that particular day because there's a limited number of matches you can give out. You can't give out, you know, the really rich guy or the really beautiful woman or, you know, whatever to, you know, thousands of people. You're just going to overwhelm them. You can only give out a certain number of times. You know, get to ration out the good people to the people who hopefully they want to talk to. We're not just, you know, trying to make all of our money off, you know, the beautiful people. Like, oh, hi, Mr. Ugly Guy. Here's, you know, this beautiful woman who's way out of your league. What, don't you want to talk to her? It's like, oh yes, I'm going to give you my money. And then the beautiful woman gets all the, you know, messages she doesn't really want. Problem. Big problem. So we're trying to do that. Okay, so what is affinity matching? Here we have 6 various people, and we're trying to, you know, figure out how to match them. And you know, the first problem, first person, age difference, much. 20-year-olds, not 6-year-olds for the most part. I'll say that, for the most part. Second part, these people actually, you know, if they actually live close together, they would be really good matches for each other. But 3,000 miles away, one's in New York, one's in LA, say, or even, you know, different countries. And that's probably not going to work that well for dating either. And the third person, hopefully, they are, you know, within each other self-selects, and we think they're actually a, you know, high chance communication. So we're going to match them, and hopefully they'll talk. And so some of the features that get tossed into these affinity models, there's religion, there's ethnicity, marital status. We don't allow people who are currently married, by the way. That's more like number of divorces type of thing, or ever married before. And people use all kinds of devices, and people have very different communication history, and actually people have, you know, a life cycle on the site where they'll be very active, sending communication. Hopefully they, get a date, they hopefully stop communicating after that. Not always. So, hopefully, the communication, if it's, if they're more active users, hopefully they'll, respond to communication better. So, they're more attractive just because they are higher communicators.
That quick question. When you say devices, you mean like Android, Apple, Windows, Mac?
Yes, they have different communication rates and actually.
Does Slack just for a Mac user? That's kind of cool.
There is talk of adding a feed. It works as long as actually getting the device attribution into the models is difficult, but yes, apparently iPhone people like to talk about it, right? I use an Android device. All of you with iPhones, I don't know. Plus, I'm married, my wife would be upset. So, here's an example of what a graph looks like. This is distance on the bottom axis. Top is communication. This is a log-based scale. Okay, so the people who are 0 to 1, 3 miles away from each other, much more likely to talk to each other than you go 15, get down to 60 miles, 250 miles. People just that distance, it's just not going to work. Although interestingly, when you get really high out there on the very high end, I don't know if this is pen pals or this is I don't understand necessarily. No one we can't as we could do actually talk to people, figure out why they do this. But they actually do talk to each other. New York people will talk to LA people, and people in the middle of the U.S. will talk to people in the UK and Australia, and we actually do have success couples up on the wall where we have people in the UK who married people, had kids who live in Australia or America. It's just it's amazing to me. Romantic, sure.
It's like in the movies.
It is, yes. Look at that. That's
Ryan, a little piece of insider knowledge of that. That means those people are the only people who say, both sides of that said, I want to be matched with anyone from anywhere. They actually marked anyone.
Yes, in order to get that sort of thing, you actually must say anywhere in the world. And those people from an architectural standpoint are both easy and difficult to deal with. It's very easy to get them lots of potential matches, but it's much harder to actually deal with the number of matches they tend to get and actually figure out which matches to give them that will result in higher communication. So we have this nice, pretty graph.
We're pickier on other axes.
Some of them, we actually had one person who broke one of the old systems who was not very picky at all, and hundreds of thousands of potential matches and just broke one of the systems. So this is the communication that happened on one particular day. This is one day. 2 summers ago, I think it was. Someone graphed all the communication. It is a little skewed where it might look like a lot of the communication is going, from this continent to this continent. That's not really true. If you see, the little white dots that are major metropolitan areas, you can see like the triangle from Texas, you can see the coast. But this like dot here, LA, a bunch of people in LA are talking to other people in LA. It all just shows up as, a dot on there, right? And same with, the whole East Coast and all that. But, it is, communication does happen over very long ranges. And all these outliers, and sure the graph looks like this, but still those people do communicate. So you can't just not match them necessarily. So another feature, something interesting. This is height. I like this graph. This is my favorite graph in the entire presentation. And what this says is if the male is much taller than the female, I'm up over here somewhere probably for most females. I can basically, any female wants to talk to me, and since not very many are actually taller than me, I don't have this problem over here. This is the short guy problem. All the short guys out there. This is the tall guy, this is the short guy. It turns out women don't really want to date people who are shorter than them. And this is born out of the data, but it still does happen. You still have these are error bars, so, short guys, you do have a chance. You have a tougher time. That's all. I'm sorry. I'm very sorry.
Just work
Yes. Okay, attractiveness. You might ask, how do we come up with this beautiful bell curve of attractiveness. And what this is the difference between the self-reported attractiveness of the male with the self-reported attractiveness of the female. So if you remember back to our questions, scale of 1 to 7, you know, how much exercise? I think one of them is actually my friends say I'm sexy. Yeah.
Too sexy.
So yes, it turns out that people want to date people as attractive as they are, and are actually not likely to send communication if they're basically too pretty for them or too ugly for them. And I was actually very surprised when I saw this graph because I thought people must lie about their attractiveness, but apparently when you're going through 150 or 300 questions, whatever it is, you just stop lying at a certain point. You're just gonna get going. You're like, I'm going to finish 1, 3, 7.
What's the x-axis?
X-axis is the difference in height between. Oh no, this is the difference in attractiveness between male and female. So take the self-reported attractiveness. Say you're 24, and the female's at 20. You subtract it, you get a 4. You're right here. You're right there.
0 to 100 scale, or?
Well, you can see the maximum range looks like it's 24-ish.
That's just a little weird.
Which at a 7-point scale, I'm guessing it's 4 to 28 if I had to guess.
Okay.
That is a very educated
How are you matching? I have a question. How are those people even getting through the matching process with that such a low feature?
They have other attributes.
guess. Well, if you have a 4, you can match with the 4s. If you're a 4 on the attractiveness scale.
Okay.
Hopefully those people actually lied, or did they just weren't paying attention?
Can their dates report back to us?
We don't have that sort of thing. We don't have any. I took out all these slides from the modeling presentation, which deals with photo analysis and some of the newer features we have that aren't just self-reported. Some of the interesting things there are even simple things, which is the quality of the photo you take, like from a professional photo standpoint, like what's the ratio of your face detection to the size of the box, like which one is stomach up, don't try and hide your gut if you have it, sorry. That's just part of who you are, don't hide it, just show who you are, and don't be too far away either if people want to see what you look like. So, anyways, other stuff like that is in there. Wow. Let's talk about exciting stuff. Okay, new design, here we go. This is version 2.0, event-based matching with Java and Groovy models. So if you remember from our previous slide, we still have a web app. At this point, we moved to Oracle. And we pulled out the store procedure into 2 pieces, okay? The first is CMP, which stands for CMP makes pairings at this point. We've changed the name officially to CMP makes pairings. And a pairing is a potential match. So the way CMP works is it pre-processes users. So it gets these events, keeps this local database. Each host would have its own database. And there's a topic. So the CMPs elect one CMP to work. Everyone updates their local database. One wins and gets to work for the user. Does a search over here, pulls back a bunch of people, runs it through actual Java-based models for compatibility, make sure they're compatible. If we don't have enough, we'll go to another query that it breaks some of the rules. Someone said, for example, I want this particular religion, but it's not that important to me, so we can break that, right? And we can do that on both sides. Although this implementation could not do that very well, which we'll get to that, maybe. So once this guy's found enough pairings, it stores them in a new table called pairings, which is similar to the matches table and that has potential matches, very similar schema. Sends the event to matchmaker, which then queries off of that same pairing table, pulls the pairings out, pulls a bunch of user data, and runs it through the affinity models, which are Java and Groovy models, based off the slides I showed before. We have different ways for different features, like attractive. And there's this nightly, so that's for a new user, this event-based. And then there's a nightly job the way it worked, to do a query off the database to find the users to run for, and just send a bunch of events into here and make, all the matches one user at a time.
It's Groovy? I haven't heard of it.
Groovy is Java with some funny syntax that makes it better, I guess. We don't use much Groovy anymore, so sorry. Okay, so problems. Oh, I did not, the animation on this side. Oh, well. Okay, so suboptimal distribution of matches. As I mentioned, we're putting events one by one. The users who come first, they get the best matches, great. I'm at the head of the list, I get all the pretty girls today, yay. And when people at the bottom of the list, they might get no one, because they, maybe only had 10 people they could be matched with, and they've all been taken, and they get nothing. That's a pretty big problem. The nightly match run taking 27 hours. That was actually the previous one. This one still had problems where I think it might have even got to 27 hours at some point. It seems to be a common problem with all these systems. Once you hit, the nightly match run is taking more than, say half the day, you have to figure out a new redesign to handle this. And we did move to optimal platform. So the suboptimal distribution, so the first try to fix it is they shuffle the loop order each day so that every person's at the top. And they, try a whole bunch of things. But then in solutions, they want to introduce an optimization problem to try and maximize the global communication within the constraints of how many matches each person can get. And we'll get to that shortly. Move to the offline platform. I'm sorry, I'm having to speed up because I'm trying to get to the exciting stuff quickly. Java models are a big problem. We really had to switch to these configuration-based models so we could roll out new releases much more. And so match distribution, I'm not going to go too much on this. So we have a bunch of females and males, and these are all the potential matches that could be made. So each edge is a match that could be made. And what we'll do is say that for argument's sake, we want to make 2 matches for each person. Okay? And some people could get 5 matches. They have 5 potential matches, some people only have 2, some people have 3, right? And so what you do is, if you just want to optimize the total number of matches, you put a weight of 1 on each edge, and you run it through a flow control problem, which you can think of as, say you have, a water station, and you want to, or a bunch of water stations, you have a bunch of pipes that connect it to the end user, and you want to minimize the cost of flowing the water through each pipe. You don't want to flow water from LA to New York and then back to Arizona. You just want to minimize the cost. So this is a well-known transportation problem, and so this works. However, we do something slightly different. Instead of having a weight of 1 to optimize the number of matches, we just put the probability of communication there instead. And so now we're trying to maximize the overall communication rate. That goes through, there's your bucket, there's your water.
So in this case,
There's the water flowing.
Isn't it better to be picky then when you're stating your affinity preferences? Because you'll have less choices and it'll prioritize you?
My opinion, you want to get the models as many people as you can. But that's, because the more people you have, the more chance you'll have some numbers that are very high that the optimizers do. If you have a bunch of very low scores, you're more likely to get passed over. So there's the final solution that comes out of the optimizer. Great. And so let's implement that. Okay, so we have the online matching systems. This is like the same system still exists. The whole matchmaker and CMP still exists. It still makes matches. And it sends logs off to this Hadoop process. And its job is to try and keep its copy of the pairing. The pairing table is so huge you can't dump it every day. That's the big problem. Okay. Second problem is don't store graphs in a database. So it's trying to keep its own copy of the pairings table up to date by passing through all these logs, and that's 2.5 MapReduce jobs to do this. When this was first implemented, it was done on EC2, and basically was working fine, and then we ended up bringing it in-house into a local system, which ended up saving quite a bit of money. This is actually a common thing with EC2. Each incident is actually very expensive, but when you're, you don't know how many you need, how many boxes you need for your Hadoop cluster, don't just figure it out on EC2, and then you can bring it in-house to save money once you know the actual hardware spec.
What's EC2?
Amazon's
Okay.
Hadoop system.
Elastic Compute.
Elastic MapReduce.
Did you use EMR?
Yeah, we
Okay.
use Elastic MapReduce. The other problem, we had a couple problems with it as well. This score, you might think, okay, we have pairings which have 2 user IDs. Okay, so we have to join user data 1 and user data 2 with pairing data, right? So in a database world, you're joining, two tables, and one table is in there twice, right? So what was done instead is there was a key value store that had all the values, and we would fetch all the data from there. It was on EC2. Sometimes the communication rate between the different nodes wasn't high enough because at the time we couldn't pick the network configuration. I think they've solved this supposedly. But we had problems with this. This system, when it was running on Amazon, crashed all the time. When I first joined the company, there were alerts, at least once a week. It was terrible. And these are, nightly matchings running middle of the night. You get, an alert. Everyone's phone is on the pager, and you're getting alerted at 4 o'clock in the morning once a week. It's just a nightmare.
Did you actually use HDFS on EMR?
All the data was stored in S3.
Okay, yeah.
Yeah.
But yeah,
But
it was transported. It was transported to HDFS.
On EMR, not your own Hadoop?
No, well, later.
First it was.
First is all on S3.
Because one of the problems we had is it all had to go through S3. There was no HDFS.
Yes, that was a problem.
EMR.
Yes, but then we brought it local. We still had all the data was sitting on S3. So when we were running it local, we would copy data from S3 down as like the start of our job, and that ended up having problems. So we ended up just doing all local HDFS in the long run. So anyways, you do the log processing to get your pairings, you do your key value store here to do the double joins, right? That outputs a bunch of scored pairings. You have a score for every single potential match. You pass that through the optimization problem. At that point, you have to go actually make the matches. So this would actually, at the time, write directly to the database. So, the other part here is there was a database dump to go through a new job to actually load into the Walmarts. And this kind of worked. This actually worked quite a bit better than the old system. The actual communication rates actually did go up. It does work. The whole flow optimization thing, that definitely works. And the problems started coming in when we started wanting to add more data here, right? So this is great. We're dumping data out of a single database, but it turns out we need to pull in communication rates, and this was the big one. So we ended up having, we couldn't fit into this Voldemort, so we ended up having an external Voldemort that was set up on like real machines. And this whole job was running in the C micro box, which is like a sort of mini, it's like a cluster in a box, you could say. So it's like the newest version is 256 dual core Atom processors with 4 gigs for each one, and each one has its own. You could call it a VM, but it's not really a VM. It's actually its own machine. And if you're not leaving the box, it's really fast, right? The inter-process communication is great. The disk I/O is okay, not terrible, but once you leave the box, you're capped at 8 gigabit, and we were maxing out the bandwidth hitting these external Voldemorts. Yep.
Well, Ryan, I just wanted to add one thing that, since it was a little bit before your time, that may be important to people that are doing this on AWS. So you notice the Voldemort cluster there. Maybe in the earlier slide, you notice there was a Memcache cluster. The first rev of this was using Memcache. but we were losing cache boxes so often on EC2 just because of failures that we went to Voldemort, not because it was durable, but because it could survive node failure and without ruining the job. So I mean, if you need to do map side joins or anything like that, don't look for something more on EC2. Look for something more reliable than cache.
Well, Amazon, I mean, I think DynamoDB would probably work for it today. But this is years ago. Okay, so years ago. Okay. Mass distribution, does it work? This is communication rate over time. So yes, communication went up. Two-way communication went up. The new system was launched in 2010 right here, and you can actually see it jump up quite a bit. And they developed new models over time that actually continue to increase the communication rate. Now it's actually quite a bit higher than this. Okay, so as I was mentioning, more data is required. Maxing out the network bandwidth is really bad. And actually getting the data into the Hadoop job is actually really difficult. There's a lot of work trying to, manipulate the data to get it passed around. And so we decided to build services to collect the data in real time. And then once we had that service, like the communication data was all behind the service. There were these bandwidth limitations, and at the time it was all JSON, which is about 10 kilobytes per user. And we switched to protocol buffers and then dropped it down to 500 bytes per user. So it's a 20x reduction in bandwidth, which we then wasted away by adding a whole bunch of more features. Because that's what the modeling team will always want. They want more and more data, constantly more data. They want to get it to your model systems, and you have to deal with this. You can't be dealing with the serialization problems that JSON has. Protocol buffers I've done tests that are about 6 times faster on deserialized and serialized than JSON, and also have much better garbage collection. And we can't reprocess people fast enough due to database load. This goes back to each pairings, the pairing table. Don't store a graph database in Oracle. Use Neo4j, or in our case, we actually use a more specialized system. We just use straight key value store, where the value is actually a list of the people who could get matches. Because that's how which goes back to why aren't we using Neo4j? Well, because a graph database is too much. We don't need it. We're not trying to do graph traversals, no fancy network algorithms. We just need a list of user IDs, and a little bit of data for each one, and don't overcomplicate it. Just keep it as simple as possible. And so, service-oriented architecture, what?
Sorry, did you guys ever, you benchmarked, so I know you went through the protocol buffers a while ago, but I don't know if you've circled back like Avro or any other.
Okay, so I have a story for that. I had 3 days to implement this feature. I had JSON, and JSON back store. I had to get this out to production. Went to the website for Avro, and it's terrible. I've gone recently, it's still terrible. And one of the worst websites I've ever used. There's no real, how do you figure out how to use it? I don't know, you go look at the source code? I don't know how you're supposed to learn Avro. I really don't know, okay? Went to the website for Thrift, saw all this RPC stuff. I'm like, I don't need this stuff. Went to the protocol buffer website. It's perfect. You go there, you can tell, a professional put this thing together. It's obviously well done. Google uses it for all their services. I'm sure it's good enough for me. I don't have Google's problem, Today, I might choose Avro if I had enough time to figure it out, because there are technical reasons why Avro is better. It's the schema is protocol buffers you have to compile ahead of time. So any schema change you have to recompile. Avro you don't have to do that.
Any corporate consideration, or is that just off the scope?
No corporate. We're not looking for RPC. We're just looking for a data serialization. That's all we're looking for. So protocol buffers is actually a very good fit for us. And I will get you how we use it a little farther. So we have basically a bunch of different types of services. We have the event-based services. Matchmaker is still here. We have CMP. We have KCP, which is another version of CMP, which does different rules. There's alpha mail, which sends emails. And there's this event listener, and all its job to do is to take various events and say, okay, I'm going to call this sequence of REST-based services. Okay, so does everyone know what REST is? Everyone knows what REST is. I don't have time to do REST. Please. Okay. So REST-based services, we have a way to get matches. We have Feature X, which is a way to calculate expensive features, like photo features are very expensive. Some of the text analysis is very expensive. So it takes an entire protocol buffer for a user and returns back another protocol buffer for the features. And this allows the modeling team to actually can go and add new features. And because protocol buffers is forward and backwards compatible, you can add new things into it. You can basically add something new here and add something new in the scoring layer down here, and nothing else in your system has to work. It has to be modified, right? You don't have to go change matching user service, which has the same protocol buffer definitions, just because you changed feature X or you changed score. So it allows you this flexibility where you don't have to schedule your releases perfectly. We're like, okay, well, let's go release 10 services at the same time with our new definition, because someone we don't care about added one new, double into some protocol buffer that we're not even using, right? So let's see, we have feature X score service. This does scores. It's really simple. I'll get to the implementation for that. Matching user service is a data aggregation service that collects all the user data. So it's sort of the central point for all these systems to get user data. Parent browsing service stores the parent instead of the parent table. Match figure service makes matches, and CP service is a front end to CP. It actually sends events out to the sun. It actually has some sort of things where we can take two random user IDs and say, is this pairing still compatible and still within each other's self-selects? And that's actually very important because the redesign that I'm going to talk about does eventual consistency on the pairings. So the pairing table was, a database structure with a single, two columns. If a male was potentially matched to female, the female was also automatically potentially matched with the male, right? So each edge is only represented once, right? But when you're inserting thousands here, you have thousands here in the database, you have these locking issues, and you get these weird locking chains that would say this male is matched with this female, and then they're trying to write, 1,000 records. This person's trying to write 150,000 records, and this person's side still, this person's here, this person links back up to here, and it does not work. Really does not work. So we switched to a model where for each user we keep a list, but that list may no longer be accurate. By the time you actually go to make the match, it may be hours since this person's last processed. And so the CP service is critical for doing a real-time check. Is this guy still okay to be matched with this lady? Or guy to guy. We do have compatible partner sites. Okay, service-based features. They're all REST-based services. Almost all are data-oriented services. So taking matching user services, job is just to provide user data. The pairing service is just to provide pairing data. The scoring service does scoring. That was another data service. So the data services, they all have sort of the same approach. There's always a way to get or modify a single element. A get gets the single element. A post is an update. A put is to create, and a delete is a delete. And then we have multiple elements. Fetches, which is a get either from the URL, you have the list of IDs, or you can actually put a body even on a get. You don't have to do a post just because you have a body. So you can do a get with a body that fetches a large list. And all of these produce and consume both JSON or protocol buffers directly. So we actually do have a binary server-to-server communication protocol, and that uses standard content negotiation. So the header is accept content type, accept application protobuf. You put that on your header and into the headers, and automatically getting back this strange list of characters here. And yes, we use JAX-RS providers. I have posted these up on the forums for the proto stuff library. which we use, but he didn't want to make a Jack Soros thing, so we will probably open source it ourselves. But this is very useful, very good feature of
Do you find
Webservices.
places, you know, you're talking about Voldemort and network congestion. Do you find places where you're calling REST services and that the HTTP overhead of the rest of the HTTP protocol is sort of more than that 500 bytes that you're looking at?
We did, but we switched to Netty for all our communication. We were using Apache HTTP4, the HTTP4 client. We had real problems, major problems with some of our bulk calls, which I'll get to how they work. Where just randomly you have some call that would normally take 50 milliseconds, suddenly take 500 milliseconds. You're like, oh, it must be blah, blah. No, it's just because the Apache client sucks. There's a Netty version. It's async HTTP client.
So instead of Apache conversation.
There's a Netty version plugin for, we use Jersey. So if you're using Jersey client, I highly recommend switching to the async HTTP client, which is based off of So our clients, there's a generic client for each service. So we have like a generic one that will handle anything, but we actually make implementations for each service that handles, you know, give me a user, right? Give me just for simplicity's sake, you have, you know, a simple interface that says, give me a user based off the user ID, and it just gives, and everyone knows how it works. You look at it, you understand, it's going to get the user. And it has all the get, post, but delete. Multiple elements. So there is a straightforward get. So say you have, you know, 50 elements, you want to go fetch it. It will go just fetch it. But it also supports a batch call. And this uses a scatter gather implementation. So the way it works, say you have, say 10,000 users you want to fetch. It will split them up into batches of, I think we're using 100 at this point. But you try different batch sizes in your network configuration. In your backend, you can try different batch sizes. The configurable batch sizes and a configurable number of simultaneous calls. So all the servers are behind a load balancer bit, right? So we might send out 10 simultaneous calls for batches of say 100. Once a single call comes back, we'll send out another one. So we have no more than 10 in-flight connections from one particular call, so one call can't eat your entire network. And it just gathers it back together. This is not guaranteed to return every single element the way it's implemented. You could implement that way if you wanted to, you can have to throw exceptions. But in our case, if someone has 10,000 potential matches and we only pull back 900 or 9,900, who cares? They'll get it tomorrow. It's not really that. You have to ask yourself whether it's really critical to get every single result back, or you just want, you know, don't take more than 2 seconds to return all this data. Just go get me something, and I need, you know, I'm servicing a real user here. I need to give them some matches right now. Okay. Protocol buffer based by default. Yes. So the client actually will set all the headers, but it does set that we'll accept JSON or protocol buffer. This is protocol buffer, then, you know, comma JSON. So it will use protocol buffers, but we actually can point it to services that aren't protocol buffer based and just get the JSON back. So we can just make a protocol buffer that represents what that service returns. And we actually use this to match users, which I'll show. To handle your JSON. And there's a configurable number of retries for get, put, delete, and also there's one retry here on the dash. So even if one times out after, I think it's the 1 second timeout we have, which is actually really long. They'll actually retry automatically for you. And same for get, puts, and deletes. Get, puts, and deletes are all supposed to be idempotent. If you're designing REST service, please follow that. You do posts for anything that's not reviewable. Okay, current day. This is matching user service. This is a data aggregation service. And this job is to aggregate a bunch of data from a bunch of different places. So we have a bunch of services. We have a database, of course. And this is the general the general way all of our services work the same sort of way. So we have what the service name is here, we have the version number, we have the category, and then the ID. And if we have more categories, you do a /category/ID. And then if you have some parameters, you can do question mark, blah 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 blah. Right? Supports full and partial updates. So for example, it stores all this user data. You just want to update the communication data. You can actually do a post that actually just posts what the new communication data is for this user. Notice, pull the data from I'll show you how it works, but it pulls the data from the Voldemort, merges it in, stores it back, handles obsolete version exceptions for you, which is key value stores way of handling transactions. And that works, has thousands of different data attributes, and it's all in like a nested structure. So there's a user profile up here, there's all the, like the relationship questionnaire stuff is here, all the user factors, which is like the dimensions I mentioned before, right? So they're all here, and they're just actually grouped by each model that we have. And it's all the communication data, and all that data is only about 4 kilobytes each compressed, which is really impressive actually. Key is the user ID, the value is something called the user proto. And here is implementation for a put. So a put says I need to fetch a user profile, goes to this profile service, which is something that the front-end guys, this is a very old service, doesn't need to be rewritten, but right now it returns JSON. So we ask for, we hit the service, returns back JSON, and it automatically deserializes into our protocol buffer. The code is, you can't tell looking at the code that that's what it's doing. And if they go and change it, so this actually can send protocol buffers, it'll actually just work. We have no code at all changed to that number, right? We fetch a bunch of user data from SOA, which is what we call our database. This is Oracle. I think it's single Oracle actually. Is the user account closed? If it is, we'll go and delete it. This is due to a race condition, okay? So puts and deletes actually are handled the same way. The only difference is if you call a put and the users actually close their account and the time it takes, right, before you actually get to it, it'll delete it, keep your key value store up accurate, and it'll return back an error code saying, sorry, what you try to do isn't possible. I think it's 403, but it's one of the 40X's is designated to mean sorry, race condition. I think it's
Conflict?
it is 409 conflict. Thank you. Yes, we'd be just in conflict back, and it handles it for you. Assuming they're not closed, we'll actually go and extract the features. So this is like photo features, string answers, stuff like that for feature X. This actually posts entire protocol buffer. This one right here, right? This is one protocol buffer that gets created. This gets sent here and gets added into a bigger one. Then we fetch user activity from user activity service, and there's other services I don't have on here. Merge all of these protos, these are all different protos, together into one giant proto and store it here in the key value store. Okay, so this is optimized for retrieval. We have to fetch thousands of users as quickly as we can, and this works really well. It's actually very fast. Here is a partial update. So for example, I mentioned you could just post communication data, and it goes and gets the data from the Voldemort, modify. So this actually gives the path to the subcomponent. This is a completely generic update, right? So we say, go update user activity dot communication. Okay, or it might be user activity slash whatever. So it goes into your protocol buffer and does the same sort of thing you'd expect with some sort of JavaScript library or something like that. And we'll go and find what it needs to modify, modifies it, and then merges it back in, stores it in here, handles obsolete versions for you. This is really nice. And one of the things we have to do with this is, I mentioned before that we have a header that says accept application protocol. We also put a header that says what the class of the protocol buffer is, what that particular URL represents. So that in this case, this generic thing needs to know what is the, it could be anywhere down the step, and there's all kinds of protocol buffers in there that the same path has to deal with. So this takes a general message, which is the interface for all protocol buffers, and actually figures out what it needs to do inside the JAX-RS provider itself. So that's completely abstracted away. Let's see. More. And a get. So it fetches, you get a get for user, and even the bulk gets work the exact same way. We get the user or set of users from the Voldemort. We calculate runtime values, which is stuff like day since last login and other things like that. Merge it and return to user proto. Speaking day since last login, when you're dealing with models, you have this problem of reproducibility. So you want to be able to rerun something you did, 2 weeks ago. So if you just return back, if you're dealing with dates directly in this user proto, you're going to have a problem. Because you're dealing with, then everything you're dealing with has to, figure out some way to pass in what the reference time is and all that. Instead of that, this matching user service has a property, simple, flag that says, pretend today is, May 16th. And everything calculated values, days since last login, days since registration, days since subscription, all these kinds of values that are time-based, right, are all based off deltas from this configuration parameter. When you're doing testing in production, it just, new date time and deals with that. Okay, move through a few more.
So when you're writing the code, you want to say a particular date so you can see if the result is the same or different?
When you're testing, yes.
Yeah,
Because you need to be able to reproduce,
You got to be able to reproduce.
a run that ran 5 days ago, right? But in production, you just want to use the same thing in your testing as you use in production. So you just use this, these calculated values like, days since last login or any other sort of date-based elements. Yeah. Pairing service. I talked about this a little bit before. So the one interesting thing here is we have different types of matches we make. If you use our website, we have this what if feature, which is supposed to be this super relaxed version of what you're looking for. So we might only break religion a certain amount, and say we'll break it in some crazy amount, for example. And so what's stored here is a pairings proto. Just to explain, I think you really have to understand this. Pairings proto is just for a particular user. We have a list of what's called pairings. A pairing is like a user ID, whether it's relaxed or not, which is whether it's broken, right? Whether their self-sets are broken on each side. So user relax, candidate relax, and distance. And that's just because distance is a pain to calculate. We actually have all the data to calculate distance in users. But anyways, so we have that as a proto that's just a repeated list of this very small compact object, and which makes some of this very easy. Get, put, and delete is very straightforward. But there's a special delete here. And what this is for is you have this pairings, which are these potential matches. But how do you keep it up to date? A match just happened. We need to go update this list. And the way we do it is we have this special URL, which for each match that gets made, gets fed through the event, matches get put onto the message bus, comes in through event listener. This listener makes a call, or possibly 2 calls, right? One for each side. That says, hey, this pairing is no longer available for this user, to this candidate. And if it's a 2-way match, it actually has to go both sides, right? So this will actually, the way it works is it just pulls the entire record out of Voldemort, deletes it, and stores it back, and resolves a version conflict, so it'll just keep trying over and over. There's 4 data elements for pairing, 0 to 10,000 of pairings per user. For a service like this, I highly recommend storing an empty list if you have no potential matches for a user in this case, or whatever case you might have. And a missing value just means this user has never been processed, right? If you can't tell the difference between this person has been processed and got 0, and this person has not been processed, you're having a bad time. Okay, Yes, and there's one store in our key value store for each type of match, which makes it easy for the key value to see user and pairings list. Okay, scoring service is a little different than the other ones. This is a stateless calculation service, and it was originally written to handle scoring a particular user based off a model. So given a particular model name, this is scored. And it knows how to fetch data from various remote data sources for particular URLs. There's more than this. And it knows how to fetch for this, but it also, we're going to write the code, and it's pretty easy to write. We actually could post the data you want to score into the service itself, instead of it fetching it itself. And we have many debates on which way is better. Network wise, it seems to be identical. The real question is whether you want every single client to know how to fetch your own data, which is probably a bit of a problem. Let's see. So the idea behind this is that every single model will be put in this one place. We want to release a new model to multiple, we're doing scoring in matchmaking, we're doing scoring in the offline system. We just want to push it out to one place, and this would be the one place to push out new models. All the models are, all the models are based off this model frameworks library, which is on the next slide, which supports, protocol buffers or maps or database result sets, all kinds of generic ways to get data. Yes, we may redesign this a little bit. Let's get to the model frameworks. Okay, model frameworks. These are all JSON-based model definitions. So the way it's typically set up is at the top it'll have various, you can think of this like header information, like the type of attributes. You can define variables, stuff like that. And at the bottom is the actual implementation of the model, which is take this, variable name that's defined up above and multiply it by this and add this. And so here's some examples here. Right at the top, you can say same religion, and it's set to this user.profile.religion equals candidate.profile.religion. This works. This actually works. This goes into protocol buffers, and for the user protocol buffer, actually there's one giant protocol buffer that gets created, which has the user, the candidate, the pairing. Okay, so let's take the user, take their profile, take their religion, take the candidate, their profile, their religion, and actually, check if they're equal. We call functions. So this is a binning. So you subtract the ages from each other, and you pass in how to bin them. So in modeling, you tend to do these binning things where, like, if the age is 0 to 1 is a particular bin, 1 to 3 is another bin, 3 to 5 is the next bin, right? So this lets you define the bins here and then pass it into a bin method. If you've ever actually had to deal with writing models in Java code, you understand just how wonderful this is. It's really great. This is slated to be open source once it's finished, which, it's never ending.
Do you have a skewed binning based on male to female versus female to male? Because
yes. To be clear, we don't just have user and candidate, we also have male and female.
Mm-hmm.
So there are other formulas that we can do where we can do male.age minus candidate.age, right? Or
right.
Sorry, male.age minus female.age, and that won't work for the same-sex models, but that will work for the gender models. And we actually do have quite a bit of those.
So you handle like height, basically. We're like
yeah, we can handle height with this thing, right? With the male.profile.height minus female.profile.height. And we have all the weights, if you remember. So each bin, down below, this ends up making this like this string, which you could think of, m_f_ bin 14 type of thing. Right, and down below you say bin 14 has this weight, bin 13 is this weight. And if they don't have a value for that, it's 0. And so you just multiply them all together, add them together, and it works. So let's see, offline. We have rewritten everything into a what we call Spring Conductor. This uses Spring Batch, and there's a new plugin for that, which I can't remember the name of it off the top of my head. Anyways, what's really nice about this is, say your dump PBS Hadoop job fails, it'll know how to automatically retry, and it'll send an email if it fails. I mean, there's all this sort of configuration stuff that if you've had to write multi-step Hadoop jobs before, being able to handle this sort of programmatically and actually have like a real flow control is really nice. And this handles, some of these are not Hadoop jobs, some of them are just very good Java processes, right? So it can handle all of them and handle retries and all that for you.
Quick question. You said you have a Hadoop plugin for Spring Data, right? Can you?
I think it's actually Hadoop data.
Yes,
So it's
Spring
called
Data.
Spring Data Hadoop thing, which David here actually helped contribute and fix some of their bugs. Apparently we're the first major user there on their plugin. Never dealt with some of the things you have to deal with. And this is the final slide. This is the new offline run. If you remember before, there's all this delta log processing and all that, which is awfully complicated. The new, I don't have them on here, but the new system, you get a user list, just list of user IDs literally in a file, right? That gets passed into two different Hadoop jobs. There's an MUS dump, which is a match use service dump, and PBS dump, which is a pairing service dump. And the way it works is there actually might be multiple files in the user list. So the map side is just nothing, it's just cat. And on the reduce side, for each user ID, each unique user ID, right, it will go and fetch it. And you set the number of reducers. So this is generating, in our case, where we have 512 nodes, we are generating 460 files. So some subset of the number of nodes you have available on your map reduce to your Hadoop system, right? It has to be a constant size. So this needs to generate 460 files. This also has to generate 460 files. Okay, everything here, everything's generating 460 files. And that's important because the way map side joins work is similar to a database join in parts if you actually have like clustered indexes. Like if you have partition clustered indexes, it works exactly the same. But you have these 460 files here, 460 files here, and user ID 1 is going to be in a certain file here, and it's going to be in the same file number here. So it'll be, I think it actually just says mods, it's probably file 1 for each one. Right? And so these just do merge joins, where it just goes through, Hadoop itself will do this for you. It'll actually just do a merge join and go through, file, this mapper will handle file 1 and just go line by line, and, but it never has to backtrack, which is nice, right? So you take the user data, the pairing data, you do the join on this. The output of this is you have the candidate ID, you have the user data, and you have the pairing data, okay? And then you join that again back onto the user data and pairing data again, and at this point you have the user data, the candidate data, whether the pairing exists in both directions or not, and the pairing data. And that is what we need to run our models. So that gets combined into one new protocol buffer, gets passed into model frameworks 3. And the output from, this is on the map side, the map just outputs a user ID, candidate ID, and score. And the reduce job just combines them all into one line. And so you have scored pairings, which for each user ID, you have a list of all the candidates and scores for that user, right? So user 1, they could be matched with user 2, 5, and 6, and the score for 2 is 53, and so on and so forth. Okay? So we have all the scored pairings. Now, distribution models, as I mentioned, they're flow control, right? That's a very simplified version of what actually happens. We actually have multiple flow jobs with multiple limits for how many matches each person can get. And they go one by one through them. And so we actually will run both say you want to A/B test flow 1 versus flow 2, it'll actually do both of them here. Then we have this way of merging the two results, which I'm probably losing people. I'm sorry. Let's pretend this doesn't exist, and so it just goes through the distribution algorithm, gets a list of matches to be made. And so the output here is what matches we want to make. We send this to delivery, which is a very simple script at this point, which just goes to the list, has multiple threads, and goes and does puts appear on match bigger services. Hey, make this match, make this match, make this match, make this match. Millions of matches. The output of that is you have issued matches, you have failed matches, which means you have like timeouts or database locking problems, like every retry failed for some reason for a particular match. And you have invalid matches, which most of these are race conditions. Right, this job takes a few hours to run. People may have changed their self-selects. There are matches that you made in between. It's like match already existed exception. Well, yeah, the user said, give me more matches at 2 o'clock in the morning. Because they were drunk coming back from work. And so everything in blue. Final step after this is done, there's an archive step which takes all this stuff and sends it off to the modeling cluster, which is actually a standard Hadoop cluster with much more memory per box, much more disk. And that's available for the modeling team. And they have a job that actually runs through each day and puts it into Hive tables and does more standard, Hadoop data analytics stuff. If you're interested in that, his Cloud's presentation would be good for that. How did I do on time? 3 minutes to spare. So apparently this is a 3-hour presentation. It's rushed into 1 hour and 20 minutes, and apologize. I hope everyone enjoyed it and are there any questions?
I have a question. This job just keeps running and running. Is there anything that your customers do that feeds back into the system to change the model, or is it all by the modelers?
Yes, there are retrain.
Yeah.
Models get retrained all
Right.
the time, and we will dump new JSON configuration files for the models for here. But also, just the user data and pairing data changes every day. If someone changes their self-selects, their pairings change, and also their user data changes as well. And this is a real-time dump from our live systems, right? So this dump actually hits like matching user service.
Okay.
It does gets, right?
Yeah.
A get for each user that dumps all the data out. And I forgot to mention, this gets dumped out. The format is user ID tab, and then we base64 encode the protocol buffer.
Okay, but there is some training within there.
There's training which is done over here on the modeling cluster to generate new JSON files for the models. And we have A/B testing and other, it gets very complicated very quickly.
Right.
And some talking its own.
Sure.
Which I probably can do talks.
Did you ever consider partitioning the users, like say comment, and having only those different matches?
There are actually 3 jobs, 3 of these runs a day, 1 for each continent, you could say. The funny thing is our Australia run is called Asia, don't ask. And it mostly works, but the problem is that we allow people to stay anywhere in the world.
Right.
If you remember, right? So what we do is we sort of trick it so that you can only be the user side 1 time a day, right? So if you're in the UK, you're put in the Europe run, and you are eligible to get your full matches there. Other people can get matched with you, that does happen, but your matches will mostly come from that run.
When trying to avoid n-squared problems, matching is the real trick. And geometry is an obvious way to cull it down, but
The main trick is you don't want to have, because this is actually worse than n-squared. Because the search phase at the start is added on top of that. So you want to you want this pairing data to be big enough that your models have enough data to work with, but not so big that it kills your joins here. Because the amount of data, like this join right here, this output right here, is the killer. It's worse than actually scoring. Okay, this is actually really difficult. If this gets too big, this will become your bottleneck. right now we have it tuned so that this is actually our bottleneck. But we have a different set of pairings. I mentioned the what if pairings, which is actually a bigger set. And on that one, this is the bottleneck. If we run out of simulation.
You had mentioned that you switched from JSON to protocol buffer.
Yes.
What were the considerations like? Why you?
The main reason is we were bandwidth capped. We were doing, one of our Voltworms was outside the cluster, and we only had 8 gigabit that we could use. And the JSON was literally maxing out the bandwidth for 2 hours straight. And actually causing performance problems. Because we're hitting live systems like, it was just, it wasn't working. And actually there were timeouts and other retries that were just making the problem even worse. When we switched to protocol buffers, it did solve that problem.
So was there like a particular size of the JSON payload which?
Yeah, it was only 10 kilobytes per user. We're not talking about huge JSON or a huge amount of data. This is basically counters of communication by day. So on this day, this person had 5 of this type of communication, 1 of this kind, right? And there's like 9 counters per day, something like that. And it doesn't seem like it should be that much data, but it was just, yeah.
Could you go to the delivery section of the model there? Because you say issued matches, failed matches, invalid. Are those user inputs, so then the user is inputting certain response
Well,
to something?
in here, okay, so here's a list of every match you can make. It's just a list, user ID 1, user ID 2, type of match it is. Whether it's a
For
two-way
each
match
user.
or one-way match. For each match we want to make.
So you put like a key
So
value.
well, it's not really, it's pairing value, right?
Okay.
So it's actually like edge if you're talking about graphs, right? So you need both sides.
Gotcha.
Right, we want to match, Jane to Joe, and so on and so forth. And that comes up to here, and so we call it a matchmaker service, which is REST service, right? And based off the return code that comes out, right? 500 goes into the failed matches, all the 400s go into invalid matches, and the 200s go here. So this service is actually very simple. Up here has some database handling and other things to actually store the matches and subunits.
So the failed matches are kind of within the system based on the matchmaker service. So that's
If
before you even get to the
errors.
user.
This is complete, yes, these never got to the user, probably.
Okay.
Probably. Did not get to the user. Most likely this is stuff like with block contention to the database, timeouts. We actually have a retry at the end that tries it again and
So user input, does that happen and then go to like the model? Where does the user input kind of go?
the user
It
input
always goes
ends
back
up
to the beginning.
going way back over to here. There's real-time systems that feed in to the matching user service that this dumps out of, and also the pairing service, right? So we actually dump directly from our Voldemort source every night. And the Voldemorts are actually handling real site traffic at the time and are completely live. So we get around the whole delta log processing that we used to have by just directly dumping from our data source. And those dumps are very fast, they're like 3 minutes, a couple minutes. Basically, yeah.
You mentioned some A/B testing. How do you value the success of one over the other?
That's a really good question.
Actually, how do you divide up your A/B groups?
A/B groups is actually a bigger question. But assuming you're making matches of a certain type and you want to compare them, what we've gone to, there is merger which tries to do it, but it has big problems. A lot of the stuff we do here is we actually chirp between 2 different ones. So this one will say make 2-way matches based off model 5, and this one will say make 2-way matches based off model 6. And so we have various graphs of like communication rates. And if the model is actually significantly better, you see this, you can see it on the graph, right? If it's not significantly better, you see pretty much a flat line in terms of communication rate or whatever you're trying to model for. It's actually a really difficult question. You should ask the modeling guys, because they don't know how to solve it.
So communication rates is kind of a gauge as to how well your models are working. In other words, if they talk to each other.
There are other things we can use, or could theoretically use. Profile views is a lesser form of that. And there actually is some instances where particular types of people, emails in particular, won't initiate communication, especially with particular ethnic or certain backgrounds, certain parts of the country or certain countries even. And that's just because, you know, social norms that are not supposed to do that. But it turns out that if you view someone's profile, it will show up on the other side of their newsfeed, like, you know, Jane looked at your profile. And that's sort of used as sort of a sideband communication to say, hey, you know, I looked at your profile 3 times, you can send me a message or not. Yeah. So there is that. That's actually, the problem is that data is much noisier. And we sort of get around it by training on two-way communication. So we don't have to deal with who initiates, we just have to say, did they end up talking to each other? But there are flaws in that. Any questions?
Have you seen like the usage rates of the whole system go up based on the architecture?
Yes, subscription rates went up actually on the new redesign. Actually, the new redesign made a significant increase in matches. I'm going to say, why is that? We actually tried to exactly reproduce what the old system is. The only difference is, as I mentioned before is two-way pairing. So we made a pairing between, you know, Bob and Jane. Jane automatically sees Bob. But there are database problems where that's very slow. We can only reprocess something, you know, in the tens of thousands, actually almost maybe hundreds of thousands. Anyways, now we can reprocess people instead of, you know, tens to hundreds of thousands a day. We can process, you know, 2 million a day, and we can add more boxes if we want to go faster, right? So just the fact that we're reprocessing people faster before people in the sometimes run out, or we also have this weird thing where we create this pairing and then this person would come in and we delete it because they didn't, we're only trying to get 55 to this person, and you know, this person would have been number 56, so we're just going to like delete it. So we're basically undoing our own work because we're doing these like bi-directional pairings. And throwing in a one-directional way actually significantly increase the number of matches we can make. And also, to your point, it does allow A/B testing. So you can make pairings for a certain, you know, 10% of your people. They're just what you consider crazy, right? I didn't get into it, but basically, we have this rule-based system for how to do relaxation, and the new system is designed so that you can basically plug in models there where you can, for each self-select, how much out of bounds is it, and then have the models learn how good or bad that particular amount of out of bounds is, or in combinations of, you know, if both age and, you know, religion are bad, then it's really, really bad, or maybe it's not so bad. Models like that. That's, sorry to be clear, that's machine learning models, uses Oracle Rabbit. It's a very good online learner and handles text-based classification.
What's the name?
Oracle Rabbit, B-O-W-P-O, Rabbit,
VW.
VW. Just search for VW, please. But also, I think I can send you a presentation that, if you're interested in the modeling side, Vince, or Bob, sorry. You open up where the world have 2 names. Bob. Any other questions? And obviously, you know, we are hiring. There's lots of very interesting jobs here, very interesting, you know, things to do. All across the board, whether you're, you know, whether you design web pages or you look at backend systems or you're a modeler or anything, we have plenty of jobs out there. So we have a job site, and